Okay, I think we're rolling. Hi, my name is Judy Mizraki. Hello, how are you? I'm going to write that down so that I do get credit for this assignment. Judy Mizraki. Okay, that's me. Hello, hello. Hi, how are you? I'm doing number 3. You see number 3? Number 3 right there. Can you see it? I think you can see it. Prove or disprove that if P A slash B plus P not A slash not B equals 1, then A, B are dependent. Okay, fine. Video is required. So, I'm going to go ahead and write down exactly what it is that we're trying to prove. We're trying to prove that if this, we want to know, right, this plus this, can you read? I want to make sure you can see that. Yeah, you can see that. Good. Equals 1. Does this imply that A and B are independent? Okay. Well, by definition in chapter 1, we know that for A and B to be independent, that's the same thing as saying that the probability of A times B is equal to the probability of A times the probability of B. Okay? So we want to find out if this implies this. As you guys know, I'm sure already, what this is just notation for is this. The probability of AB over the probability of B plus the probability of not A and not B times not B over the probability of not B equals 1. Okay? Before we go further, the first thing I want to do is I want to get rid of all these the not thingies, because the not things kind of scare me a little bit. The easiest one to change is this one. We know that the probability of B, okay, I'm just going to kind of put this in a little box up here because this is what we're trying to talk about, okay? Cool, can you see that still? Awesome. This, of course, is going to equal 1 minus the probability of B, and the reason why is because you can only have either B or not B, so the probability of B plus the probability of not B is 1, because you're 100% sure that you're either in A or not in A, and that you're in B or not in B. You're 100% either going to eat the brownie or not going to eat the brownie. Either you're a fish or you're not a fish. There's no other option, okay? So, that being said, what about here? This is kind of gross, but it's actually not so gross, because we can use De Morgan's law to change it into this. Right? Okay, beautiful. Which is the same thing as this, right? Let's see, what else can we do to this? What else can we do? Oh, okay, I'm sorry. Sorry about that. This here is the same thing as saying, this is the same thing as saying the probability of A plus the probability of B minus, I hope I'm right, probability of A and B. And the reason why is because if we use circles, right, and I want the probability of being here, right, I like circles, that's the same thing as saying and this is A and this is B, okay, that's the same thing as all of A plus all of B, but the problem is this part here that's in both A and B, I counted twice, so I have to subtract one of those. That's where this comes in, okay, cool. So let's write that all out, and I'm just going to go ahead and like write this in for this and this in for this, okay? So we get, can you still see that? Yeah. The probability of AB over the probability of B. I'm a high school teacher, so I'm sorry if I talk a little bit funny, but you know, some people do have to hear my voice all the time, so at least be glad that you're not them. Plus the top part here, which is, let's see, 1 minus this. So we're going to get 1 minus the probability of A minus the probability of B plus the probability of AB, okay? Divided by 1 minus the probability of B. And all that's going to equal 1, okay? Well, now we kind of have our work cut out for us. We're going to multiply everything by this, of course, just because we want to get rid of these nasty denominators. Sorry. Okay, and so that's going to give us this. That's going to give us, I'm just going to go ahead and like do the obvious, multiplication through. So this times this is just going to be PAB minus PB, PAB. Okay, that's this part. And then this part's just going to be this, because this is going to cancel. So we're going to get plus the probability of B minus the probability of A times the probability of B minus the probability of B squared. I'm just going to go down next line, plus the probability of B, or no, sorry, minus. Wait, no, wait. Yeah, plus. Wait, no, okay. Multiply by, yeah, plus, sorry about that. Probability of AB, okay, good, is going to equal probability of B minus the probability squared of B, and the reason why I just multiplied this through here. Okay, cool. Well, right away a bunch of stuff goes bye-bye, right? Because this cancels with this, okay? This cancels with this, okay? This cancels with this. I think that's everything. So then we just get the probability of AB. Oh my God, this worked! Yes! Can you still see this? Probability of A times the probability of B is going to equal 0. 0! Which means that PAB is what? Boom! That's right. I'm sorry about that. I just totally wrecked that epic moment of awesomeness. PB, which means, lo and behold, A and B are independent. Awesome. The end. Well, I'll do a fancy mathy. Therefore, awesome. Hope you enjoyed it, because I did.